Hello everyone, I'm Peter Schaknat, the Managing Director of Schaknat Electronic GmbH, and today we are optimizing a Scania R. Today we have a really beautiful Scania here with us, and as you can see, it's in my absolute favorite color, which is black. The customer just bought it and it's currently being modified. Just a quick rundown of some key facts about the vehicle. This is a Euro 6 engine from the year 2016, an R, 16.4 liter displacement, DC16 V8 engine with 3,500 Newton meters of original torque. It has an exhaust gas recirculation system with a variable turbocharger and a selective catalytic reduction, or SCR system, so it comes with a particulate filter and AdBlue system. The vehicle has roughly just under km. The customer is here today because he bought the car used and would like to have it checked again on the test bench. It has a relatively high fuel consumption. In normal traffic, it uses 37 to 38 liters, which is clearly way too much for a car like this. That's why, as I said, especially with Scania, since we have a lot of experience, we always like to go in with the testers as well. I always like to do that to check whether the intake air temperature sensors are working properly, whether the differential pressures in the particulate filter are correct, to make sure that everything is technically in order with the peripheral systems, because that, of course, has a big impact on fuel consumption. Especially when it comes to winter, there used to be radiator nets so that the engine would reach operating temperature more quickly and not lose so much heat. But now, with the newer model years, or with engines in general, there are modified thermostats. In the summer, there was often the problem that the cylinder head or the coolant circuit would get too hot. So now there are modified thermostats that allow the engine to run a bit cooler, because many people have already had problems with cylinder heads, though this is more common with the 6-cylinder engines like the 730 and less so with others. Today, we're going to optimize the truck using the app. So the process will be very clear. We'll start with an initial measurement, then optimize using the app, then do our final measurement, and finally we'll review everything together on the monitor. As you can see here, this is just a standard axle, a regular drive axle. Many people say, especially with heavier loads, for instance, like in the timber industry with long logs, that people have generally moved away from these outboard planetary axles, even though the drive axles themselves are actually very robust. You just have to make sure not to engage the differential lock incorrectly, because the outboard planetary axle simply consumes way too much energy, and overall, it just doesn't really pay off in the long run. That's why with drive axles, knock on wood, I don't want to jinx it, I honestly can't even remember the last time I personally had a broken drive axle. So knock on wood, the new systems, and this is not just at Scania, but also with other major brands, are proving to be relatively robust. Okay, so now we're measuring the rear axle again. You can see the other one has already been unloaded over there. With Scania, in such a setup, it's also very important that we go underneath around the axle housing again with 2 slings and pull it all the way down with the hydraulic cylinder so that we have sufficient pressure on the axle. Of course, when the eddy current brake is applied properly and you have, let's say, 3,500 Newton meters, and if we optimize it, maybe you'll get up to 3,900 to 4,000 Newton meters, then you obviously have a significant counter torque. And that's exactly why we have to make sure we have good traction on the axle. It's also often the case that people say, yeah, the truck knows when it's loaded, so you should actually load it up on the test bench, because otherwise it won't deliver its full power. Well, that's not really true. The vehicles still do this via traction. They measure it through the available traction. The better the wheel's traction is, the better the performance will be. That's why I always say it makes a lot of sense to load the axle. If you have more pressure at the front, the truck actually delivers its maximum available power. But that has nothing to do with the airbag pressure or with the load in general. It's simply because the electronics are so incredibly sensitive that if they detect even a slight slip where the wheel would start to spin, they immediately cut the power. By pulling the axle, specifically the wheel, into the roller, that's the important part, and we've tested this countless times on the test bench. If I have 100% traction, it doesn't matter whether it's loaded or not, it will always show me the correct power output. And just recently we tested the 770 Scania. We always measure it as a tractor unit, just a standard 4x2 without any load, and we always get the factory rated power output. So just to clarify, because a lot of people always say it depends on whether the vehicle is loaded, but that's not entirely correct. What's important is that the wheel has traction. All right, I went a bit off on a tangent there, but I'd say it's strapped down now. So I'd say let's start the initial measurement and then we'll see our monitor.
All right, Renee, go ahead and get in. But let me quickly grab you a floor mat. We've custom cut them for every truck and every steering column. For the passenger footwell, there's the V. All right, go ahead and get in. Let's start with the measurement. With this big scanner here, measuring a 37 Scania is just really cool. You put it on, grab it, and pull it down into the roller so we have traction. With the 37, that's obviously essential. Then bam, 11th gear. 11th gear is the direct gear, and we want to measure it once at the limiter. We've already activated the test bench mode, so basically Vmax is switched off. Now we will proceed to measure up to 2x2, and please be aware that this measurement is intended to last for a full 17 seconds. After that, execute the procedure one time and allow the engine speed to drop below 800 revolutions per minute. At that point, the inspector will automatically know that it is time to begin the official measurement. Remember to keep your hand on the neutral position throughout the process, and there it goes. So as we accelerate, we're hitting 110, then 120, and then, if you can believe it, even in neutral, the car reaches a top speed of 147 kilometers per hour. But then, the moment you come off the gas, the deceleration experience is just absolutely and completely brutal. All right, then we'll see each other again at the results.
The other one has now completed the initial measurement, and he said the car has just under the specified kilometers. Now let's go ahead and take a look at the initial measurements together. Down here below you can see the RPM axis again from 800 up to 2,400 revolutions per minute. On the right here you see the torque axis, and on the left here the horsepower axis. You can see down here on the graph now the lower curve represents the torque curve, and the upper curve shows the peak power. As you can see from the data, it should have 730 horsepower, but what we're actually getting is 670 horsepower and just about 3,447 Newton meters of torque. So we're getting close to the peak value. But what we also noticed on the test bench, as Andre mentioned and made very clear to me, is that on the test bench, it just doesn't want to perform properly. And you can see that here. You can see we have a small torque peak at 1,100 RPM, and then it drops off again. And even at the lower end, it just doesn't really get going. The engines used to have a few issues with the variable vane adjustment, that is the guide vane adjustment. Basically, this means that the turbocharger, we have a large turbocharger where the guide vanes inside can be adjusted. This allows it to compress the wheel or make it larger again. In other words, as the engine speed increases and more air is needed, the vanes open up and allow more airflow. For lower engine speeds, so that the turbocharger already builds up proper pressure at the bottom end, I close it in the other direction, so that at lower RPMs I already have more boost pressure. But of course it's clear that if the adjustment gets stuck or doesn't work 100%, then things like this can happen. Or what was also common with these models were issues with the charge air temperature sensors. I've experienced this several times myself, and my customers have also mentioned it often. When I have extremely high fuel consumption or something that could be related to this, the LAE air temperature sensor could be the cause. The LAE air sensor is a combined sensor, air pressure and air temperature, and these air temperature sensors tend to fail quite often as well. With these models, the tricky thing about this sensor is that it doesn't show any error codes. The customer only notices that sometimes the engine delivers full power and other times it doesn't, sporadically. The reason for this, which I happened to notice by chance on the test bench, is that when idling, it simply displays 50 degrees higher charge air temperature. Of course, the engine control unit then thinks we're in the Sahara Desert at 50 degrees ambient temperature and reduces the engine power accordingly. So what happens then, logically, is that the system starts to scale back. It goes into a kind of limp mode, and in this limp mode, it always injects a bit more fuel, which leads to high fuel consumption. This is often a tricky problem because it's hard to diagnose the sensor, as it doesn't show any error codes at all. So I only noticed this by chance myself because I've also had cars with this issue. Of course, it could also be the case here again that there is a variable camshaft adjustment at the bottom end. I've seen this quite a few times now, where the overpressure valves in the rail pressure systems were already worn out and would always open slightly. Unfortunately, this also doesn't show a proper error code, at least not until relatively late. So to rule out this issue, you can also see it in the curve. Specifically, you should go ahead and check the system during the measurement as well. But we won't go into detail about that now. We're going to optimize now. The other person will now flash it with the application, and at the end, I will inform the customer what they might potentially need to replace or what else they should watch out for in order to avoid increased fuel consumption. But of course, I'm assuming the car is functioning properly, and my optimization will logically only work if all the peripheral systems are also 100% in order. But that's exactly what the test bench is for. You can also see up here that a typical curve would go up here, hold steady for a while, and then go down here. And you can see with the torque peak, that's exactly what the customer confirmed, that it just doesn't come properly, it doesn't want to, and that was also the main reason for coming here, because the fuel consumption at 37 or 38 liters in normal use is, of course, way too much for today's standards. Well, enough talking for now. The other one is already driving the car now, and is already doing the initial measurement.
So now we're flashing the Scania. Here it's mainly about reducing fuel consumption. So the first step is to open up the onboard diagnostics port, also known as the OBD port, which is located right here. Then we can take our adapter and simply plug it directly into the port. There, now it has finally and securely clicked into place. Okay, the next step is to turn the ignition on, but be careful not to start the engine. It's very important to minimize electrical draw, so make sure to turn off any power consumers. For example, ensure the radio is off, the air conditioning is off, all the lights are off, and your phone is unplugged. Now we can optimize the Scania. To do that, we select Scania in the Schaknat App. The new adapter then connects automatically. Now for the EMS engine control unit, we're going to code it to eco mode. See, just like that, LCKKW already accepted. Now we've done the coding. Now we are going to do the flash. For that, we will go ahead and press the flash eco button right here. It's important to always put the phone securely in here. This is so we don't run the risk of walking away with it, and also so the data connection does not get interrupted during the process. And finally, so the adapter always maintains a good, stable connection to the phone. This works via Wi-Fi, and now basically we have a complete connection from the server via satellite directly to the phone, then from there via a wireless network, and finally through the CAN bus to the engine control unit. And now the app is already smart enough to automatically retrieve the specific adaptation values, for instance. How is the vehicle actually being used, and how does the driver typically operate it? Has the engine performance adapted downwards, meaning has it become noticeably weaker over time? That happens quite often, and there's also the saying, it's well broken in. That's a high level of adaptation. That's what's being read out now, so to speak. How is it being used? Does it have a passenger crane on it, or is it a tractor unit? The manufacturer does care, but they just make sure the vehicles come off the production line, regardless of what gets added later. Whether a dump body is added, a fifth wheel plate and heavy-duty superstructure, or maybe a crane or whatever else. And with that, we're basically done. Most of the time, that's not even relevant. You usually just see the trucks coming off the assembly line, and that's where we come in. And for that, we have the tool, the Schaknat App. Then we can perfectly customize it individually. Individually is the key word here. We're not hauling 40 tons of bananas here, nor are we hauling 40 tons of wood. We also don't have a passenger crane on here or anything like that. But you hear about all sorts of different uses everywhere, just like the beet trucks right now. It's sugar beet season. Exactly. Now we'll set the transmission control unit. Let's also set the transmission to eco mode. That part goes by really quickly. Then we will go ahead and clear the errors one more time. So we'll read and clear out all the errors just once. You can also do that with the application, and then we will be ready for the initial opening measurement.
He has now done the baseline measurement, programmed it to eco, so engine in eco mode and transmission in eco mode. Now we'll take another look at it together. As I mentioned before, you can see here again, at the bottom is the RPM axis, here's the torque, and here's the horsepower axis. We're now comparing the lower curve, which is the torque curve, red is the optimized one, and blue is the original. As you can see, originally we had 3,447, and now the baseline torque is 3,028 Newton meters with an increase of almost 80 more horsepower, so 751 horsepower. Of course, it's now about 20 horsepower stronger than originally stated, but I think we've also measured significantly less before, which you can clearly see from the curve. You can see here that we now have a much earlier torque increase, and it also holds that longer. But before that, I quickly went through everything again with the diagnostics, recalibrated the turbocharger, checked the charge air temperature sensor, couldn't find anything wrong, recalibrated everything again, and only then did I optimize the car. It was probably actually due to the turbocharger. There are also procedures where you can recalibrate the EGR, recalibrate the turbochargers, and you can see here as well that it's not making any control movements. So you can clearly see what a difference that makes. And of course, if the truck already has very full torque at 800 revolutions per minute, then naturally I also have a completely different fuel consumption because every revolution requires a filling. Low RPM is when I use fuel the most efficiently, and that is the whole thing with these kinds of engines. They have the displacement, they live off the torque, so they have to run at low revs, otherwise they start consuming a significant amount of fuel. So as you can see, we have now achieved almost an increase of 450 Newton meters of additional torque, which the engines can very easily handle. In fact, we've already done some with significantly more torque. These engines are commonly used in diesel generators, stationary engines, or installed in marine applications. And there, I drive with much more torque and higher peak power, but the cooling is different. That's why you can run much higher power and torque, because the cooling and the consistency are always there. With trucks, of course, you have warm, cold, winter, summer, and you have to factor in the ambient temperatures. Well, as I said, it's obviously a great result now. I was hoping we could solve the problem this way, but I still told the customer to keep an eye on whether there are any changes in fuel consumption, because that's what really matters to us. We also see it very often that customers come to us when they can't find certain faults for diagnostic purposes, so we go searching for the cause. If it's sensors or something, we do that, but we rarely or never do purely mechanical work here. It's mostly about the electronics these days, especially with things like the charge air temperature sensor, as I've always explained to you. It might seem like a small thing, but it has a huge effect. So you always have to keep an eye on that, and that's where we're a bit of specialists. It always bothers me personally when I can't find the fault, so I really dig into to figure these things out. Because of course, if a truck then uses 5 or 6 liters less fuel, that's a huge benefit for the customer. Sure, performance is one thing, but on the other hand, fuel savings are what really add value today. Well, I'm really satisfied, and I hope the customer is too. Let's see what he says. We've reached the end of our video on engine and transmission optimization for the Scania R. I used to do a lot of the Danish models, especially the first Euro 6 A, B, C variants. They're starting to become a bit rare now, not extinct, but less common, because the new models are coming out more and more. Abroad, I still see them quite often, but in Germany, they're getting rarer. But I love that engine. Back then, they were the strongest, and I did a lot of them, so I know that engine really well. The customer also got our new adapter from me, and I gave him a training session, explained how it works, especially for things like updates or service functions, like reading out error codes. In the future, we'll add more updates, so maybe you'll be able to reset a service or teach in a clutch, things like that. We might add those features soon. And for Christmas, our customers get our little Christmas truck with chocolate inside because you need some comfort food, especially in the logistics business. It goes down well. The customer will get one from me too. So if you're interested in this topic, check out our website at bwschaknat.de. Feel free to call, email, or WhatsApp US. We're always available for you. So thanks a lot for watching. Take care and see you next time. Bye.